In the last class, we have seen what is a spectral decomposition. Right? In today's class, we'll learn about another decomposition called LU decomposition. Right? Let's recall what is a decomposition. Breaking a big matrix into a smaller matrices so that the product of all those matrices will give back you the original matrix. That's what I say, decomposition of a matrix. Right? Let M be a matrix. If M can be written as a product of M1, M2, Mn, then I say M1, M2, Mn. What are the factors of the matrix M? Many decomposition exists. Spectral decomposition, LU decomposition, QR decomposition, and whole lot of things. In today's class, we are going to learn about LU decomposition. What is LU decomposition? Every non-singular matrix can be decomposed as a product of a lower triangular matrix L and an upper triangular matrix U. That is, a non-singular matrix A can be written as a product of L into U, where L is an upper triangular matrix and U is L is a lower triangular matrix and U is an upper triangular matrix. Right. There are many methods, and the factorization is not unique. Different methods use different strategies over there. Right. The method I'm choosing here is I take the diagonal elements of the upper triangular matrix as 1. Nothing wrong, you can take the diagonal elements of lower triangular matrices also as 1. Right? Now, L, let it be L11, 0, 0, L21, 0, 0, general representation, L21, L22, 0, and L31, L32, L33. And upper triangular matrix, the diagonal elements, I'm going to take it as 1. So it becomes a 1, U12, U13, 0, 1, U23, 0, 0, 0, 1. Now, we know that two matrices are said to be equal if the corresponding elements are equal. So what we do is we'll perform the actual multiplication of these two matrices, then equate that to given elements of a given matrix. That pops out, evaluates L11s, L22s, and a whole lot of things. Right? Then we'll substitute here. That gives the L and that gives the U. So, right. So how to decompose? A, you write it as a L, U, and U returns a unit upper triangular matrix. Basically, this decomposition used to solve a system of linear equations. We know that a system of linear equations can be written as AX equal to B. Now we decompose this A as a LU, right? Then this one, the given system of equations becomes LU into X equal to B. Then we change the variable here. We take this UX as a Y, right? Then this equation becomes Ly equal to B. Substitute the L, substitute the Y mean Y1, Y2, Y3, and B is all the right side elements, right? Now, then by forward substitution, that yields Y, right? Plug in that Y here, that yields X by a backward substitution. It's simple. Finally, that gives the solution vector X, whatever we want. Now, let's see how to decompose. You take an example. Solve this system, 10x1 plus 3x2 plus 4x3 equal to 15, and 2x1 minus 10x2 plus 3x equal to 37, and this equal to minus 10. We write the system in a matrix notation as AX equal to B, where A is the coefficient matrix, X is the column matrix of variables involved in the system, and B is the right side elements. Now what we do? We decompose this A and replace that A by LU and let's see how to solve the given system of equations. Now, A, I plugged in, L, L1100 and so on. U, the diagonal elements are taken as a 1. Now, if I really multiply these two matrices, that yields L11, this, and so on, right? So there are 9 elements here and there are 9 elements here. Equate term by term, element by element. We know that two matrices are said to be equal. The corresponding elements are equal. So this yields L11 is a 10, right? So L11 plus U12 equal to 3. Plug in this L11 and it's a simple algebra. You do all the things over there, substitute slowly. So here I have done all the algebra. So I got L22. Similarly, you get a L23 and right, and L33 and so on, so forth. So finally, I got my L. This is my L, and I got my U. This is my upper triangular matrix. That's how we decompose, right? Now, to solve that system, we take solve this system. We know this system is nothing but AX equal to B, where A is written as L into U. So this becomes LUX equal to B, right? Now we are taking UX equal to Y. Then Ly will become B, right? So here, let's take this L, plug in here, Y, if X is X1, X2, X3, we know that Y is Y1, Y2, Y3, plug in that Y here, plug in the B, right? Then, if I plug in all the things here, then by a backward substitution, right? This reads as X3 equal to 1, X2 plus X3 equal to this, and so on. So go by a backward substitution. That yields X1, X2, X3, right? Basically, we get Y first. Then plug in that Y here. Then that yields X. So the required solution then becomes 2 minus 3 minus 1, right? What I want to say here is take this L, right? Plug in here. Plug in that B, right? That by forward substitution, that will give you Y1. The second row will give you Y2 when you substitute this Y1. Third row will give you Y3. Take that Y1, Y2, Y3. Then we know that this UX equal to Y. So I've taken that U, plug in that U here, plug in X, X is X1, X2, X3, and the Y we found out in the last case, plug in here, then it becomes UX equal to Y. Then you solve the system, right? Here, you got that Y. Then here I have substituted that Y here. Then U here, X here, and Y. Y just now we found out, right? Then this by backward substitution, that will yield X3 equal to 1, X2 equal to this, X1 equal to this. That's by backwards. That's a simple thing, right? So finally, the required solution is 2 minus 3 and 1. So what does LU decomposition says? It's pretty simple. Every non-singular matrix can be decomposed as a product of a lower triangular matrix and an upper triangular matrix. We write A as LU and we take a unit upper triangular matrix, then equate, then that will evaluate all the elements, whatever you want there. That's how you get the decomposition. Then how to solve a system? AX equal to B is the system. Take A as LU, then LUX equal to B. Take that UX as Y, intermediate variable over there. That will yields Y. Then plug in that Y, that will yield you X. That gives the required solution. So that's how we solve the system of equations, right?